I have here three linear equations of four unknowns. And like the first video where I talked about reduced row echelon form and solving systems of linear equations using augmented matrices, at least my gut feeling says, look, I have fewer equations than variables, so I probably won't be able to constrain this enough. Or maybe I'll have an infinite number of solutions. But let's see if I'm right. So let's construct the augmented matrix for this system of equations. So my coefficients on the x1 terms are 1, 1, and 2. Coefficients on the x2 are 2, 2, and 4. 2, 2, and 4. Coefficients on the x3 are 1, 2, and 0. 1, 2, and 0. There's, of course, no x3 term, so we can view it as a 0 coefficient. Coefficients on the x4, 1, minus 1, and 6. 1, minus 1, and 6. And then on the right-hand side of the equal sign, I have 8, 12, and 4. 8, 12, and 4. There's my augmented matrix. Now let's put this guy into reduced row echelon form. So the first thing I want to do is I want to zero out these two rows right here. So what can we do? So I'm going to keep my first row the same for now. So it's 1, 2, 1, 1, 8. And that line essentially represents my equal sign. And if let's see, what I can do is let me replace the second row with the second row minus the first row. So 1 minus 1 is 0. 2 minus 2 is 0. 2 minus 1 is 1. Negative 1 minus 1 is minus 2. And then 12 minus 8 is 4. There you go. That looks good so far. It looks like column or x2, which is represented by column 2, looks like it might be a free variable, but we're not 100% sure yet. Let's do all of our rows. So to get rid of this guy right here, let's replace our third equation with our third equation minus 2 times our first equation. So we get 2 minus 2 times 1 is 0. 4 minus 2 times 2, well, that's 0. 0 minus 2 times 1, that's minus 2. 6 minus 2 times 1, well, that's 4, right? 6 minus 2. And then 4 minus 2 times 8. Minus 2 times 8 is minus 16. 4 minus 16 is minus 12. Minus 12. Now what can we do? Well, let's see if we can get rid of this minus 2 term right there. So let me rewrite my augmented matrix. I'm going to keep row 2 the same this time. So I get a 0, 0, 1, minus 2. And essentially my equal sign, or the augmented part of the matrix. And now let's see what I can do. Well, actually, let me get rid of this 0 up here, because I want to get in a reduced row echelon form. So any of my pivot entries, which are always going to have the coefficient 1 or the entry 1, it should be the only non-zero term in my row. So how do I get rid of this one here? Well, I can replace row 1 with row 1 minus row 2. So 1 minus 0 is 1. 2 minus 0 is 2. 1 minus 1 is 0. 1 minus minus 2, that's 1 plus 2, which is 3. And then 8 minus 4 is 4. There you go. And now how can I get rid of this guy? Well, let me replace row 3 with row 3 plus 2 times row 1. With row 3 plus 2 times row 2, right? Because then you'd have minus 2 plus 2 times this, and they'd cancel out. So let's see. The zeros, 0 plus 2 times 0, that's 0. 0 plus 2 times 0, that's 0. Minus 2 plus 2 times 1 is 0. 4 plus 2 times minus 2